Hello kids, in today's class we are going to learn the factors properties from RS Agarwal book. So this content it is not there in NCERT book. So these properties we are going to learn from this book. Okay, so I'm talking about all these four properties written here. So the first one is if A is divisible by B, then A is divisible by every factor of B. So what it says is that supposedly we have a number A. I'm taking example here. Okay. First. So for the first example is if A is divisible by B. So let's say we have one number A. Let us take a number 48. Okay. And this 48 is divisible by the number B. So here I am taking a number which divides 48 completely. So let's take 4. We know that 4 completely divides this number 48. Okay, so if A is divisible by B, then A is divisible by every factor of B. So kids, what are the factors of B? Factors of B, that is 4, is 4 itself, then 8, 12, 16 and so on. And if you see this number A, this is completely divisible by 4, by 8, by 12 and with 16 also. So the same thing has been described here, that if a number is divisible by any number, let's say B here, then that number will also be divisible by its factors. Okay, so this explains the first property. Now coming to second, we have if A is divisible by two coprimes B and C. So again I'm taking a number A. Let's say I'm taking a number A as 30, and this A, it is divisible by two coprimes B and C. So kids, we know what are coprimes number. Coprime numbers are the number which do not have any factor in common except 1, right? So here I am taking two coprime numbers as 5 and 3. Both 5 and 3 divides A completely. We know 5 multiplied by 6 will give us 30 and 3 into 10 is 30. So if A is divisible by both coprimes B and C, which is true here, then A is also divisible by their product, that is B into C. Now the product of B into C is 15, and we know that 15 also divides the number A completely. Okay, so this is this property that if a number is divisible by two coprimes, then that number will also be divisible by the product of those two coprimes number, right? Next, if A is a factor of each one of B and C. So here what it is saying is that A is a factor of each one of B and C. So first I am taking B and C. I am taking two numbers here, and A will be factor of both of those numbers. I am taking B as 8 and C as 12, and now I want A something like that. It should be a factor of both of them. So I am taking A as 4 here. Okay, so I hope you have understood what I have done here. I have taken two numbers and then B and C, and A is the number which is a factor of both of these two numbers. So what it says is if A is a factor of each one of B and C, then A is a factor of B plus C also. So now let us find out B plus C here. B plus C is 8 plus 12, which is 20, and we know that A is a factor of 20 also, right? Because it divides 20 completely. So the same thing has been told here, that if A is a factor of each one of B and C, then it is also a factor of their addition, their sum. Next, fourth is if A is a factor of each one of B and C, then A is a factor of B minus C also. So let us take the same figures again here. Again I am taking A as 4, B as 8 and C as 12. And this time we are going to find the difference. That is B minus C. So what is B minus C? B minus C is 12 minus 8, which is 4. And yes, 4 is a factor of the difference, which is 4 only here, right? So this property is also true, that if A is a factor of each one of B and C, then A is a factor of B minus C also. So kids, these are the four main properties of factors which we should know. Now coming to these examples. So from here kids, I'm just taking two examples because many questions based upon these I have already covered in the exercise. Okay, so I'll start with the first one. It says in each of the following numbers, replace this star by the smallest number to make it divisible by 3. So for this, what we should know? We should know the divisibility rule of 3. And what is that? It says that the sum of the digits of the given number should be completely divisible by 3. So if sum of all the digits of the given number is completely divisible by 3, that means the given number is also divisible by 3. This we have learned in the divisibility rule. So let us take this example. Okay, I'm taking this example number 1 part 2, 7, 5, star, 3 and 6. And what we have to do, we have to find the sum here of these digits. So what is the sum? 7 plus 5 is 12, 12 plus 3 is 15, plus 6 is 21. So 21 plus this star, it should give us a number which should be divisible by 3. So kids, we know, and it should be its smallest number also, because we have to replace this by the smallest number. So smallest number, I can take star as 0 and the complete number will become 21. I can take this star as 3 and the complete number will become 24. This 21 and 24 both are factors of 3. But since we are asked to find the smallest number, we will take 0 here. Okay, so we will take star as 0 and this number will become 21 plus 0, that is equal to 21 here. Okay, and this 21 is completely divisible by 3. This is completely divisible by 3 because it comes in the table of 3 also. It's a factor of 3, right? So this is done. Now what we have to do, we have to form this number. So 7, 5, what is star? We have identified star as 0 here. Star is 0, so the number becomes 75036. Okay, so I hope you have understood how we have done this. We know the divisibility rule for 3. The sum of the digits should be, all the digits of the number should be either 3 or a multiple of 3. So when we have added all this, we have find out the last number to be 21 plus star. And now we have to find the value of this star, the smallest value of this star, so that the complete number, the sum should be a multiple of 3. So it is 0 because 21 is a multiple of 3. So we have got the complete number as 75036. Right? Similarly, you have to do the rest of the questions also. Next we have in each of the following numbers, replace star by the smallest number again to make it divisible by 9. So kids, again to check the divisibility rule for 9, we have the same thing. The sum of the digit of the given number, sum of all the digit of the given number should either be 9 or should be a multiple of 9, right? So let me take the first example here. It is star 7, 8, 3 and 5. So what we are going to do? Star plus 7 plus 8 plus 3 plus 5. This is right. So now 5 plus 3 is 8 plus 8 is 16. And then we have 16 plus 7 which is 23. So star plus 23 should be divisible by 9, right? It should be divisible by 9. Now let us see what we can take here so that the complete number is divisible by 9. So in the table of 9, after 23, what we have? 9 multiplied by 2 is 18, 9 into 3 is 27. So 9 into 3 is 27. If we want to make this number, complete number as 27, we will have to add 4 to it, right? So if we add 4 to this number, this complete number will become 27, which is completely divisible by 9. So I am replacing this star with 4. 4 plus 23 is 27, and this 27 is divisible by 9 completely. Okay, so that means we can take star as 4, and now our number becomes 47835. This is the number which we wanted here. Okay, so this is again easy, and again I am repeating, we should know all the divisibility rules here to solve these questions. Next is, in each of the following numbers, replace star by the smallest number to make it divisible by 11. So the divisibility rule of 11 says that the difference of the sum of number at odd places and sum of number at even places should either be 0 or multiple of 11, right? So let us take this third example here. We have 9 star 11 5 and 3. This is the number given to us. Now what we have to do, we have to find the digit at odd and digit at even places, right? So sum of the digit at odd places is star plus 1 plus 3, which makes it star plus 4, right? Next, sum of the digits at even places. I am writing this as S dot E. This will be 9 plus 1 plus 5. 9 plus 1 plus 5 is 15. So we have got the sums. Now what we have to do? We have to find the difference. Will be, this is star plus 4 minus 15. This will give us 11, right? So star minus 11, this is, or you can see, yes, star minus 11 is the number. To make it divisible by 11, what we have to do? We have to put the value of star in such a way that the complete number should either be 0 or a multiple of 11. So now this is very clear that if I take star is equal to, here, if I take star is equal to 11, then the difference will become, the number will become 11 minus 11, which is 0, and which is according to the divisibility rule of 11, right? So what we have done, we have taken star as 0 here. So our number becomes 901153, right? So this is how we have to do this question. Now, next we have here is important note. If A is divisible by two co-primes, then B and C, then A is divisible by product of B and C also, which we have done. Yes, we have understood this property. Now we have to find the prime numbers between 100 and 200. So this is a range given to us, and we have to find the prime numbers in between them. So what we are going to do, we are going to use the same logic, the same rule, that if a number is divisible by two co-primes, then it is divisible by their product also. So that means what we can do here is, we can see if the numbers, they are divisible by the prime numbers. And what prime numbers we have to consider here is, we know that the higher end is 200 here, right? So what all prime numbers we can take is, we can take 2, we can take 3, 5, 7, 11. After 11 we have 13, right? Now if you multiply 13 with 13, that is their product. This product is 169. 14 into 14. 14 is not a prime number. We can simply ignore it. But again, product of 14 is 196 and product of 15 is 225. So here are 15. If we are multiplying, if I am taking two number as 15 here, then this product is greater than 200. So we have to ignore this. We have to ignore 14 also, because it is also not a prime number. So here we have to check till 13. Same thing has been also written here. Examine whether the given number is divisible by any prime less than 15. If yes, then it is not a prime, otherwise it is prime. We know what are prime numbers. Prime numbers are the numbers which have more factors than 1 and the number itself, right? So if the given number, it is divisible by any of these prime numbers, then that means that is not a prime number. And if it is not, then it means it is a prime number, right? So let us take the first example, 117. So kids, if you 117, we clearly know it is not divisible by 2 because we don't have an even number at the end. Now let us try this with 3. So for 3, the simple thing is add all the digits. 7 plus 8 plus 9. 9, and 9 is a multiple of 3. That means this number is divisible by 3 here. Okay. And after that, test the divisibility of this by each of the prime numbers. We find that 117 is divisible by 13 and 3 also. It is divisible by 13 also, that's correct, and it is divisible by 3 also. So since it is divisible by the prime number, that means it itself is not a prime number because it is coming in their table. It is getting divided by the prime number, right? So it is not a prime number itself. Now coming to 139, it is not divisible by 2. Now the sum is 13, which is not divisible by 3 here, right? It is also not divisible by 5 because it doesn't have 0 or 5 here. With 7, what is the formula with 7? We have to take first number as is and subtract twice of the number at unit place, that is 18. So 18 minus 13 is 5, which is not divisible, divisible by 7. So this is also, complete number is also not divisible by 7 here. Then we have 11. If we will try this with 11, this is also not divisible by 11 because sum of the number of the odd place is 10 and at even is 3. 10 minus 3 is 7, which is not divisible by 11. Correct? So this is also not divisible by this number. Now let us try to divide this by 13. It is clearly not divisible by 13 also. So this number is a prime number because it is not divisible by any number, any prime number less than 15 here. Okay, and similarly you can check for 193 also. Now coming to the last part, to find the prime numbers between 200 and 400. So kids, again we have to find such two multiples which define this range, and 20 multiplied by 20 is the number which define this range. So what we have to do, for the given numbers we will try to divide them with the prime numbers less than 20. Okay, less than 20. So if these numbers, they are divisible by the prime number less than 20, that means they are itself not a prime number. Okay, so let's start with the first number, 263. So 263 cannot be divided by 2 because this is not even. And to check it for 3, what we will do? 2 plus 6 plus 3, which is 11. So this is also not divisible by 3. Not by 5 also because it is not 0 and 5. Let's try with 7 here. So with 7, this is 26 minus 7 multiplied by 2 multiplied by 3, that is 6, 20. Again, this is not divisible by 7, right? As per the rule. Now coming to 11. For 11, we have sum of even place as 5, odd place as 6 only. Difference is 1, which is again not possible. Now we have to check it with 17 and 19. So let us try this with 17 first. We have 17, 1, 17, and then here 9, and then 7 here, right? And this is not completely divisible. Similarly, it is also not divisible by 19. So we have checked here less than 20. We have checked it dividing with all the prime numbers less than 20, and it is not divisible by any prime number less than 20. That means this number is itself a prime number, right? Now similarly what we can do here is we can check for the other given numbers, and the criteria is again the same. We have to check that the given numbers are divisible or not with the prime numbers less than 20. If they are divisible, that means they are not prime, or else they are prime numbers. Okay, so kids, this is the only part which is not present in the NCERT book, and so for that reason I have covered this content from this book, and all the exercises from RS Agarwal, they are also covered. Okay, so I just want you all to practice these all questions at your home, and if you have any queries, please email me. So I'll see you all in the next class now. Thank you.